Okay, today we're going to learn about quadratic graphs and their properties. This is section 9-1, and the standard that we're going to be covering is FIF7A, which is to graph linear and quadratic functions and show the intercepts, the maxima, and the minima. So we've already talked a little bit about minimums and maximums in preparation for the air test, but we're going to look at that a lot more in depth in this chapter. Okay, so the goals for this lesson are to be able to graph quadratic functions of the form y equals ax squared and y equals ax squared plus c. There's going to be 5 different levels of accomplishing this goal. I hope that you will know the goal, fully understand the goal, use the goal to solve simple problems, use the goal to solve more advanced problems, and ultimately what I would like for you to be able to do is adapt and apply the goal to different and more complex problems. So some important vocabulary that you will come across in this chapter, and some of this you're already familiar with, but the quadratic function, we've talked about that, standard form of the quadratic function, the quadratic parent function, parabolas, we've talked about that before, the axis of symmetry, vertex, we've talked about that, minimum, and the maximum, and we've talked about both of those. But we're definitely, by the end of this lesson, you should know what all of those words mean without hesitation. So in a quadratic function, the solutions are every single point that's shown on the graph. So if you were to look at this red line, those are, every point on that line is the solution to the equation y equals x squared. And as you can see, the graph is not at all linear. Linear means that it's a straight line. This is not a straight line, it's a curved line. So that tells us that this is a quadratic function. And anytime you have something raised to the power of 2, when the x variable is raised to the power of 2, we know that it's going to result in a quadratic function. And this is called a quadratic equation, y equals x squared. A quadratic equation in 2 variables can be written in the form y equals ax squared plus bx plus c, where a, b, and c are real numbers and a cannot be 0. Because if a was 0, then we wouldn't have a parabola. Our graph wouldn't end up being a curve, so it cannot be 0. Now, if in the back of your mind or on a piece of paper or somewhere, I would like for you to write down that y equals ax squared plus bx plus c, and keep that in the back burner of your mind, because we're really going to look at that in more depth as we progress through this chapter. You'll understand later on why I'm telling you that's so important. So the equation y equals just x squared can be rewritten as y equals 1x squared plus 0x plus 0. As you can see, putting a 0x and a plus 0 in there does not change our equation whatsoever. But then that allows us to know that a is equal to 1, b is equal to 0, and c is equal to 0. When we have quadratic equations in their graphs, anytime that they're written in 2 variables, we know that all the points on the graph are solutions to the equation, as we already said, and all the solutions to the equation appear on its graph. Okay, so we call this particular y equals x squared, this particular quadratic function is called the parent function. And I want you to notice that the graph represents the function because each domain value, remember the domain is the x, each x value is paired with exactly one range value. It's paired with exactly one y value. So the domain, recall, is the x and the range is the y. Every x value is paired with exactly one y value. If you look at the x value of 1, it's paired with positive 1. If you look at the x value of negative 1, it's paired with a positive 1. Both 1 and negative 1 are paired with positive 1. It represents a function because each domain value is paired with one y value, and it is represented by the quadratic equation, therefore it is a quadratic function. And the simplest quadratic function, f of x equals x squared, or y equals x squared, is known as the parent function. This red graph that you have here is the parent function because it is the graph of y equals x squared. Okay, so the key concept here for you to take note of is that a quadratic function is a function that can be written in the form of y equals ax squared plus bx plus c, and this form is called standard form of the quadratic function. So here's several different equations. Y equals 3x squared, y equals x squared plus 9, y equals x squared minus x minus 2. Notice that none of those look alike, but those are all quadratic functions because the highest exponent on any of the variables is a 2. When we graph a quadratic function, its graph is called a parabola, as you already know. There's two different kinds of parabolas. There's a parabola that opens upward and a parabola that opens downward. A parabola is nothing more than a U-shaped curve, and to graph a quadratic function, you have to create enough ordered pairs to see the shape. Then you connect those points with a smooth curve. Then we have what is called the vertex. The vertex is the highest or lowest point on the parabola. If you look back at this parabola, the vertex here would be the highest point because it's at the top of the parabola. If a parabola opens upward, then the vertex is the lowest point, and if the parabola opens downward, then the vertex is the highest point. These have special names. Okay, when I graph these functions on one coordinate plane, notice we can create a table of values. If I plug in -2 into the function x squared, well, if I square a -2, I have -2 times -2 gives me +4. If I square, and this is where it gets a little bit confusing, if I have -2 squared, when I square the -2, I get a positive, but then I'm looking at the second table here. Up above it, we've got the -x squared. When I square the -2, I get a +4. But then you can see that you have that negative in front of it. So now I have a -2 squared. Sorry for that interruption. So I end up with a -4. So when I graph the f of x function, I get the green graph that opens upward. When I graph the g of x function, I get the red graph that opens downward. Notice that g of x is nothing more than a reflection across the x-axis. So when it's a positive x squared, it opened upward in the green one. When it was a -x squared, it just flipped it over the x-axis and made it a negative, opened downward. Okay, so anytime we have an a value greater than 0, then we know the parabola is going to open upward. And if it opens upward, then it has a minimum point. It has a low point on the graph. So, and that, it kind of makes sense if you logically reason here. It doesn't kind of, it does. It makes a lot of sense if you reason with it. A is a positive number greater than 0. The graph opens upward. So, of course, it's going to have a low point. We can't say that it has a high point because that graph extends forever and ever and ever upward. So it has a minimum point, and that minimum is the vertex. But if I have a being less than 0, then my vertex is the maximum point. Because when I graph my parabola, it's going to open downward. And the way that I remember this, I always think in my mind, negative people frown. Negative people frown. So if a is less than 0, meaning if a is a negative number, my graph is going to be a frowny face. But if a is a positive number, a is greater than 0, then my graph is a happy face. Happy people are positive, negative people frown. Okay, so minimum and maximum. In words, if a is greater than 0, then the parabola opens upward, and the y value of the vertex, it's important to realize it's the y value, is the minimum value. And if a is less than 0, the parabola opens downward, and the y value of the vertex is the maximum value. And you can see what that looks like graphically. So, for example, identify the vertex of each parabola, then give the minimum or maximum value of the function. I'd like for you to pause the video and try this on your own. So to identify the vertex, well, you can clearly see the vertex is over here at -3, +2. So then it says to give the minimum or the maximum. Well, we know this would be a minimum value, and so our minimum value would be the y-coordinate, which is +2. Looking at graph B, is going to have a maximum here at the vertex, and that maximum value is going to be 5. So if we want to know what the vertex is found at 2, 5, and 5 is the maximum. Okay, your turn. Go ahead and try these. Given the two equations, find the min or maximum. Okay, axis of symmetry. So we haven't really talked about this, but you know what the word symmetry means. If you think back to before when you talked about figures that show symmetry or lines of symmetry. That means that it cuts it into two equal pieces, or if I was to fold it over top of something symmetrical, if I fold it in half, it overlaps itself. So the vertical line that divides a parabola into two symmetrical halves is called the axis of symmetry. It always passes through the vertex of the parabola, and if you look at the picture, you can see why. If I was to put a line through that vertex and fold my parabola over that line, it would directly match up on the other side. So, in words, if a function has 1, 0, then we can use the x-coordinate of the vertex to find the axis of symmetry. So the vertex is here at 3, 0, so the axis of symmetry would be a vertical line, x equals 3. We know that creates a vertical line that passes through 3. If a function has 2 zeros, then we use the average of the 2 zeros to find the axis of symmetry. So looking at this, it falls between these 2 points. So what I want to do is write down the distance from here to here. Well, from -4 to 0 has a distance of -4. We divide that by 2, and so we know the vertex would be down here, and the line of symmetry will fall through the vertex there, and it goes there through -2. Let's recap that. I don't think I explained that very well. Okay, so the line of symmetry has to go through the middle. So we know the middle can be found by finding the difference between these 2 points and dividing by 2. So from -4 to 0, there's a distance of 4 units here, right? So 4 units divided by 2 would give me 2. And since we're on the negative side of things, it would be at -2. And so my line of symmetry goes through here, which is also passing through the vertex. So find the axis of symmetry. Well, this one's easy because it gives us the vertex. The vertex is right here, so we know the axis of symmetry goes right through this vertex here at -1. So we have the equation x equals -1. Okay, now this one's a little bit more complicated because it's halfway between, so it looks like. So we don't know exactly what it is. So I'm going to find the distance between these 2 points, 1, 2, 3, and I divide it by 2, cut it in half. So 3 divided by 2 is 1.5, so x equals 1.5 would be the line that would create the axis of symmetry. Okay, and I just messed that up. It would be 1.5 units away. So if I have a 1 here, 1 plus 1.5 puts it at 2.5. Or you can use this formula that they used here and say, okay, 1 plus the 4 gives me a distance of 5, or gives me 5 units. 5 divided by 2 is 2.5. Either way you go, you get the same answer. I had wrote one way of doing it and then was explaining it a different way of doing it. But either way you go, you get the same answer. So let's go through this one more time. So we're looking for the distance between the 2 points, and then I took half of it, and so since it's 3, half of 3 is 1.5, so I go over here and I add 1.5 to that, and it puts me right here in the middle. So 1 plus 1.5 is 2.5. The other way you can do that, you can say, okay, 1 point is 1, 1's located over here at 5, or 4, I mean. So 1 plus 4 is 5. 5 divided by 2 gives me the point right in the middle, which is 2.5. So the axis of symmetry is x equals 2.5. Sorry about that mistake. Okay, so we want to find the axis of symmetry for each parabola. Pause the video and try it at this point. You can clearly see this one is at -3. X equals -3. Those are the easy ones. Okay, so this one, you can do it one of two ways. You can do the -2 plus 4 and divide by 2. -2 plus 4 is a +2. +2 divided by 2 is 1. So we know x equals 1. Or you can do it the other way and say, okay, there's 1, 2, 3, 4, 5, 6 units. 6 divided by 3, or 6 divided by 2 would be 3. So if I go over 3 from here, that puts me at 1. So the axis of symmetry goes through 1. Okay, so when we're trying to graph y equals ax squared, you can use a table of values to graph the quadratic. Also, use the fact that the parabola is symmetric. First, find the coordinates of the vertex and several points on one side, and then you can reflect those points across the axis of symmetry. So why do more work than you have to, right? If you know where the vertex is, just find points to one side of it and reflect them across that line of symmetry. And for graphs that are in the form of y equals ax squared, the vertex is at the origin, and so therefore the axis of symmetry would pass through the point 0, 0.